Okay, today we're going to do rules of exponents. This is something you would have covered in 8th grade math as well as in Algebra 1. So we're not going to spend a lot of time, but I know you need a review. So pay attention, and if you need to back me up and watch it a few times, make sure you understand how to work the rules of exponents. Okay, terms must have like variables and exponents to add or subtract the terms. So the variable with the exponent must be alike in order to combine them through addition or subtraction. Let's look at some examples. Here's an example, 3a squared b plus 2a squared b's. We're taking a group of 3a squared b's, adding them to 2a squared b's, and we're going to get 5a squared b's. Notice we don't do anything with the exponents. We just simply combine the coefficients together because the variables and their exponents are alike. In this next group, we notice there are two terms that have the same like variables with exponents, 5a cubed and 3a cubed. So we combine those together, those two, and we get 8a cubed. We don't have anything to combine with the 2a squared, so we just bring it down, negative or minus 2a squared. And that is how we simplify it. The next thing we're going to do is we're going to multiply two monomials together. I'm going to multiply 3a squared times 5a cubed b. Now, rules of exponents say when you multiply two like variables, you add their exponents. So the first thing we have to do is multiply the coefficients. 3 times 5, which is going to give us the 15, and then we're going to multiply the a squared times the a cubed, which is going to give us a to the 5th. And then there is no b in the first term, so that would be 1 times b, which would be simply b. Remember, what we did is we took the 2 from the first term, multiplied times a to the 3rd in the second term. Adding those two exponents together is how we got a to the 5th. Here's another example. Again, we multiply the coefficients first. 2 times 3 gives us 6. And then we have a to the 1st times a to the 3rd. And that's going to add the exponents, which gives us a to the 4th. We have b squared times b squared. 2 plus 2 is 4. So, when multiplying variables, we add their exponents. Now we're going to have a quick review of taking a monomial to a power. We're going to take the monomial 2a squared b cubed to the 4th power. Now, this does not work when you have addition or subtraction inside the parentheses. It only works when all the terms in the parentheses are multiplied. What you do then is you take each term and raise it to the power given, in this case to the power of 4. So we're going to take 2 raised to the power of 4, a squared raised to the power of 4, b cubed raised to the power of 4. 2 to the 4th power is simply 16. 2 times 2 times 2 times 2 gives you 16. In the case of the variable, you have a squared, which would be a squared times a squared times a squared times a squared. If we added those exponents as we did earlier, we would get a to the 8th. But we can take a shortcut. We can simply multiply those two exponents together. So when you take a variable with an exponent and raise it to a power, you simply multiply the power times the exponent, giving us a to the 8th. And in the b case, we multiply b to the 3rd to raise to the 4th power. We multiply those two and we get b to the 12th. What you need to remember, and this might help, let's take the case of the b. It's b to the 3rd times b to the 3rd times b to the 3rd times b to the 3rd. Now remember, we said our rule for multiplying would be that we would add those exponents. So if we added up those exponents, we would have gotten b to the 12th. So that's why the shortcut is easier. We just multiply the exponent to the power and still got the same answer of b to the 12th. Now let's check this out. We have 10 a to the 3rd, b to the 5th, divided by 2, a to the 4th, b to the 3rd. We are dividing. So the coefficients we divide as we normally would. 10 divided by 2 is going to give us 5, or 5 over 1. And then we look at the a variable. We look at the exponents. Now remember, when we multiplied, we had added the exponents. So when we divide, we're going to subtract the exponents. In this case, we're going to say 4 minus the 3 is going to give us 1. But where is that 1 going to remain? Since we have a 4 times in the bottom, we're going to have an a left over in the bottom, or the denominator. B to the 5th divided by b to the 3rd, we're going to subtract those exponents. 5 minus 3 is b squared, and so we're going to have b squared remaining in the top, the numerator. And so we record that. That is the simplification of this division problem. Let's go ahead and take a longer look at this. If we factored out the numerator, we would get 5 times 2, and then we would have 3 a's and 5 b's. Divide the 2 in the denominator, 4 a's and 3 b's. Then we would cancel. The 2's would cancel out, 3 of the a's would cancel out, 3 of the b's would cancel out. Notice it gives us the same result. 5 is our coefficient in the numerator. We have b times b remaining in the numerator, which would be b squared, and then a remaining in the denominator. So we get the same result simply by subtracting the exponents. It's just a shorter way of doing it instead of having to write all the terms out and cancel. We subtract the exponents and put the variable where the exponents is larger. Here's another example. This time we cannot simplify the leading coefficients, so we simply bring them down. Then we're going to subtract our exponents. 5 minus 2, we leave as a to the 3rd in the denominator. Notice b to the 3rd divided by b to the 3rd is simply 1, so it cancels out. And then we have c divided by c squared. That leaves us a c in the denominator. Here's another example. This time we can simplify the coefficients. 4 over 8 can simplify to 1 over 2. We subtract our exponents of the x variable. 5 minus 1, which gives us 4, so we have x to the 4th remaining in the numerator. Y divided by y third, so we have 3 minus 1 gives us 2, and that's going to be in the denominator. And then z squared divided by z, subtract the exponents. 2 minus 1 gives us 1, and that remains in the numerator, giving us our simplified solution. Now we're going to look at multiplying or distributing one term into a binomial. This is similar to what we did earlier, but we're going to distribute. So we multiply the 3 times the 2 first, which gives us 6. Multiply a squared times a, which gives us a cubed. Remember, we're going to add the exponents. And then b times 1, because there is no b in the first term, is just b. Bring down our addition sign, and then we're going to multiply times the second term. 3 times 5 would give us 15. a to the second times a gives us a to the third, and b times b to the third gives us b to the fourth. This gives us our solution once we distributed the 3a squared b into the binomial. This time we're going to try it with a subtraction. So we're going to say 5 times 2, 10. Then x times x cubed, we add the exponents, x to the fourth. Then we have y cubed times y gives us y to the fourth because we add those exponents together. Remember, we have x to the first times x cubed gives us x to the fourth. Y to the third times y to the first gives us y to the fourth. Then we bring down our subtraction sign and we multiply our monomial in again. 5 times 6 gives me 30. Then x to the first times x to the first gives me x to the second. Then we have y to the third times y squared, and that's going to give me y to the fifth. So that gives us our solution by distributing 5x to the first y cubed into the binomial. Now again, I know this went rather quickly, but it is just supposed to be a review. I'm going to give you some practice in class tomorrow so you can remember this skill fairly quickly, and then we'll move on to multiplying polynomials together in the next unit, next day. See you tomorrow.